In this video, we are going to go over some of the problems that are found in your homework packet. So let's first start with 31. So it's the very first problem in Goal 4. So in Goal 4, it wants us to write the ionization constant expression Ka. So this is an equilibrium constant, and it's written exactly like we've been writing equilibrium constants since we learned it in our last unit. So recall that it's products over reactants, and you multiply and divide everything. So there should be no adding or subtracting, just multiplying and dividing. So let's first write our expression, because really that's all we need for number 31. So Ka is equal to the hydrogen ion concentration times that BRO minus concentration. So we're multiplying these, and then we're going to divide by our HBRO. Now notice that these are all aqueous, and so they should all be in that expression. Remember, we want no solids or liquids, and there are some liquids in this unit, so watch out for that. Anytime you see water, you're not going to put into the expression. So that's all you need to do for 31A is just write your formula. Let's now go to B. So B says calculate the hydrogen ion concentration. So that means we want to solve for the H+. So this is our unknown. And one thing I want to point out to you is that every time an H+ is formed, so is its neighbor. So in other words, if this was a 1, this would be a 1. If this one was a 0.5, this one would be a 0.5. So they're always going to be the same amount. So this does give us some numbers here. So I have a 0.25 m molar solution. So that's this one. 0.25 is what I'm going to put in right there. And then it says my Ka is right there. So that's going to go in this formula. 2.3 times 10 to the minus 9. So I'm just going to enter it into my formula. Well, what do I do for the H+ and the BRO minus? All I really know is that they're the same amount. So if I say that H+ is an X, then I'm going to also include the BRO minus is an X, because remember, these will always be the same. So if they were to give us the hydrogen ion concentration, I would know its neighbor would be the exact same amount. And that does happen in your packet, so watch out. If you're wondering, hey, what's the other one supposed to be? I'm missing a number. These two will always be the same concentration. So I'm going to say H+ is X, so Br minus is X. And let's go ahead and put in the numbers in our equation. So I'm going to, again, here's my equation. I'm going to have 2.3 times 10 to the minus 9 equals X times X would be X squared divided by 0.250. Multiply each side by 0.250. And I get X squared is equal to 5.75 times 10 to the minus 10. I need to get X all by itself because we don't want an X squared, we just want an X. So I'm going to square root each side. And I'll press the square root button on my calculator, and I get X, which is my hydrogen ion concentration, is equal to 2.39. So actually that's going to round up to 2.4 times 10 to the minus 5. So that is my concentration, and that is my answer. Okay, let's go down to question number 33. This one's a little bit different. This is a Kb. It's written just like a Ka. So let's go ahead and do products over reactants. So I'm going to have Kb is equal to my products on this side. So in brackets, because we're multiplying these together, I just keep everything together and then close it in brackets times the OH minus. So in bases, you have the OH minus. In acids, you would have that H+. And again, these two are going to be the same amount in this example. And then I divide it by my product, which is N2H4, and I am done. And you might be asking, well, hey, what about that H2O? Look, it's a liquid, so just ignore it. So we don't put that into our equation. Let's look and see the numbers that are given to us. So it says, what is the Kb? So I'm solving for this. This is the unknown. And then it gives us each of these values. And so all I need to do is put each of those numbers right where it says in the equation, and then I just multiply and divide and I'm done. So that's how you do that one. So the little trick again is to write your KB correctly. You don't want to include water in your formula.